recording. So,
That's all that matters.
I see what you're saying. Yeah, you can't see it on the. Yeah, there we go. All right. Okay, now over here, they're giving you a little cutout of a little tiny space in here where we have several molecules of water, and you see we have two little ions in here. When I put salt into water, I get two pieces instead of one for every molecule. When I put sucrose in the water, I only get one piece for one piece. Every molecule of sucrose, I get one piece in the solution because it does not break up into pieces and form ions. That makes it what's called a non-electrolyte. What this little tester does is it measures whether an electric current is going between these two electrodes. Here's the wire that goes to the plug in the wall. One wire goes to one part of the light bulb socket. The other part of the light bulb socket comes from this connection down here. To get those guys to connect, I have to have something in the water that will conduct electricity. Or I can take a screwdriver and put it across the two electrodes here, and that will short circuit it and make the light bulb come on. So what this does is it's a conductivity tester is what it's called. And with this guy, I don't have any conduction because I don't have any ions in the water. With this guy, I have conduction because the salt forms sodium and chloride ions, and that will conduct electricity. Am I making sense? It's important for you to understand this because as we go back now and we look at, did I just mess it up? I did. Okay, let's make that a little better for you. Let's start looking at these formulas. I have over here, and I'm going to call on you by the cards. Okay, whoa, that's period 5. I want that. Period 3, what we're doing. And we'll start with Ani. Oh, no, you're doing the camera. So let's go to John. The other John. And John, I'd like you to tell me, how many pieces do I have on the left side of this equation? One. Yes, these guys are bonded together because they're not in the water. So there's only one piece. How many pieces do I have on the right side of the equation? 2. Because we get a sodium ion and a chloride ion. That means I get 2 for 1. Okay, every mole of sodium chloride that goes in the water gives me 2 moles of stuff in the water. One of them is sodium and one of them is chloride. Why is that important? Because it's the number of little particles in the water that determine how much the melting and boiling points change. And you might get on me now. If this is the boiling point here, I've got a thermometer in front of me, and this is the melting point down here, okay? They don't change normally. Now, I put salt in the water. What happens? The boiling point goes up and the melting point goes down. Both change. The melting point goes down more than the melting point goes down more than the boiling point goes up. If this goes down, it goes up 1 notch, this will go down almost 2 notches. Because I get more bang for the buck on the melting point than I do on the boiling point. So we can calculate those numbers, but we have to understand not only that the changes are going to happen, we also have to understand, get down here. We have to understand that when we have a molecule like this, look what happens. Look at the coefficient, the number out front. And Christine, would you please tell me how many pieces do I have on the left side of this little formula here? Huh? I can't hear you. 2. What's the coefficient up front? Come on, there's no number there, so what do we know? It's 1. Yeah, okay. Now, look at the coefficients that we have in the 2 pieces here. Now tell me how many particles do I have on the right side? 3 indeed. Good. You picked it up right away. Had a rough time with earlier classes, but you understand. Let's go to this guy, and let's give someone else a chance. He's not with us anymore. Abdul, you're on. Okay, how many pieces do I have on the left side of this equation? Or this formula, I'm sorry. No, it's 1 over. You're counting. You shouldn't be counting. What's the number out front? What's the coefficient? Coefficient is the number that's in front of this. Okay, so how many pieces do I have there on the left? 1. Now, I'm going to sprinkle it into some water and I'm going to stir it. Now, how many pieces do I have?
2.
Look at the coefficients.
Oh, 3.
More than that. Come on.
4.
Yes, good. You got a 3 here and a 1 here. Good, you added them up. Excellent.
And how come the first one you didn't make him say 2?
The first one is 2. This one. This guy's 3. The left side's still 1. It's always 1 because we're not in the water.
Oh, you're not plussing them. They're together.
Yeah, they don't go into particles until they go into the water.
Okay.
Okay, so I'm putting 1 mole of this stuff in the water. How many moles do I get over here?
4.
Yeah, I get 4 for 1. All right? Making sense?
4 for...
Muriel, let's let you do the next one. Aluminum chloride. On the left side, how many pieces do I have? Good, because the coefficient out front is 1. Now, over here, how many pieces do I have? Very good. A coefficient here of 1 plus a coefficient here of 3. The 2 together add up to 4. All right, let's do the next one for Connor. All right, Connor, what do we have here on the left side? Can you see it okay? Good. The coefficient out front is 1. This is the stuff that's not been put into the water yet. Now I dump it into some water, and how much do I have over here? Excellent.